What's going on, everyone? Today we'll do min stack Leetcode 155. So let's do this. Alright, so I'm going to start coding up this min stack question. I spent a while on the iPad trying to figure it out, but it is difficult to get this last point here. Get min, retrieve minimum element and stack in constant time. I do not know how to do it, so I'm going to implement it in on time for this one, but all the rest of these will be O1. And then I'll probably look up the answer later or keep grinding on it and figuring it out. But here we go. Okay. Looks like that works. If I submit it, it does work. All right, so that does work. This one, however, runs in O and time. Okay, here on my iPad, I'm going to explain to you the optimal solution for min stack. This is going to blow your mind. All right, here we go. At least it did mine, so. All right, so for example, here's the min stack here with this box. Right now, it is empty. Cool. So let's do these orders of operations. So let's push a bunch of elements onto the stack. So we can say we'll push this first one. So that's push 1. So then we have 1 on the stack. So the tricky part here is that, maybe not tricky, but elegant or smart way to do this. And you'll see this in the question hint, but it says to consider every node as the minimum. So that's the hint that it gives you. So it's not super helpful, but after doing some reading and looking at some solutions, this means that we need to have every node know about the minimum so far. So instead of just storing the 1 integer there inside that node, we're also going to store some extra data. We're going to store the minimum at that point in time. Okay, so I guess I can just put it up here. We're also going to store the minimum so far we've seen, and that is 1 in that case. Okay, so that's pushed to the stack. Let's move on to the next one, which is 3. So we push 3 to the stack. And what's the minimum so far? So we can check the previous node right here, or we can keep like a variable at the top of like min so far or something like that. Anyways, we can know what the minimum so far is, and then we can compare it with the current one that's going to be put onto the stack. Then the minimum here on this one would be 1. Okay, and then we go to the next one. We're going to put 2, same story. Minimum here is also 1. And then the next one is 0. So this one is where we're going to change the min, right? Because 0 is less than the min of 1. So now the min is going to be 0. And then we push 5, and this min is still 0 here. So now, let's say, let's see, get min is called. What do I return? I return 0, because I can just pop the, I guess I can just call top and then get the min inside there. Hopefully that makes sense. So let's say that is popped off the stack. This one's popped off the stack, and then I want to get min here. I can just return 1 in that case, because this is the minimum we've seen so far, because these guys over here are not changing, right? So that is the tricky part of it, and that came through reading a bunch of stuff. And hopefully that makes sense. Let me write it up in code, and then we can finish up this problem. So, okay, now that I've looked up the solution and reviewed some other code, I'm going to code it up based on what's in my head now and what I've diagrammed on the iPad. So this is my old code that runs in on time for the get min. So I want to make this a one time here. So let's go ahead and reset, confirm. Excellent. So again, I need a list. I'm gonna create a list up here, integer list. Final list. Sorry, we can say this dot list equals new array list. So that's what we're going to use to store everything. Okay, and then we can have private int min. Okay. Yeah, I'm trying to think if we should store a min there or not. One of the solutions I looked at, you will just look at what the min so far is, or what the last min was, and use that. So that way you don't have to store one. I think that's probably a better way to do it. So kudos goes out to all those people that did that post on the discussion boards. Okay, and then we need a push in value. So I guess this is actually not going to be an integer, right? So we're going to have like a pair, like a couple of fields that we need to store in there. So I'm tempted to just create another class here. Call it node, or it's kind of long, min stack node. Yeah, we could just make it public for now. Public int value, public int min. I guess I might need a constructor, min stack node, val and min, and then val is equal to val, and then val.min equals min. Alright, so that's how we construct one. And then we can just reference the min and the val. Okay. So typically we'd want to do getters and setters if we were writing a real production application, but we're not doing that right now. So this would be min stack node there. Okay. So then we're going to push a value onto the stack. So we can first check if list.is is empty. If it is empty, this is it's a new node. So, or it's the first one. So that means the value that we get in is the minimum so far. So let me say list.add new min stack node. Min stack node, and then the value we put in is the value, and then the min is also the value. Okay. If else list.add get top. Yeah, let me think about this. So top actually just returns that integer. So we might need one more method that just returns that node. So maybe like a private min stack node get top node. Okay, I'll implement this. Okay, and then get top node. That's fine. Let's see. Let me think about this. Yeah. So we just need to list.add. Same thing here. We're adding the value, but then we're getting the top node, or get top. I guess we can just call it get min, right? Wow. All right, that's fine. Okay, we just call it get min right here. And that is it for that one. All right, and then pop. This is a void. We just want to remove it, right? So if list dot if list dot is empty. Okay, if list is not empty, then I say list dot remove list dot size -1. Awesome. What else we can throw? Exception here. Okay, now we want to return the top, so let's just simply, I guess the same thing here. A little bit of defensive code, so if it's not empty, then we're going to return list.get size -1, right? Throw an exception. I guess we want to throw new runtime exception. Okay. Stack cannot be empty. Right, and then we also need to get the min at this point. So if this is not empty, then we say okay, let's not remove. All right, this one actually needs a little bit of modification. We need to do dot val. Okay, and then this one, return list dot get, and then we just do min at that point. All right. I think that's looking pretty good. Let's run this. Okay, wrong answer. All right, what part was it wrong? Null, 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 null. We're pushing -2, 0, and 3. Okay. And then we say get min. Okay, that's fine. So we're not actually ever updating min, which is fine. We forgot that. So push a value here. Okay. If it is empty, then we do that, and then else get the min, but it's actually math.min get min versus the value that's coming in. Okay, that looks correct. And the reason we need to do that is because the new value that's coming in could be less than the current min value. So they need to update that current state, but we don't need to update the previous ones because that's the min at their point in time of insertion. So I think that is the biggest point that I realized. So that's really cool. All right, so let's try and run this, see what we get. So we submit this. Okay, and it's significantly faster. So if you look before, My submissions were 531, 417 milliseconds, and now it's down to 7 milliseconds, which is excellent. All right, so that is it for this tutorial. So thanks a lot, everyone, and see you next time.